Hi guys, welcome to Mama's Tutorials, and today we are doing my favorite topic, which is titration, which is just a method of analysis in which the solution of a non-concentration is used to determine the concentration of another unknown solution. We are using what we know to find out what we don't know in the other solution, right? So we've got titration pipettes, an exact volume of one solution and reacts it with another solution delivered from a burette, right? You will see now just which one is the burette and which one is the pipette. So in this way, the number of moles that have reacted in each solution can be calculated. You will see how we'll be calculating our number of moles using titration. So in titration, one reactant is slowly added to the other in the presence of an indicator. We slowly add the other, and we'll be adding it using the burette, right? So the indicator changes color when the reaction is complete. A change of color is a sign that the reaction is complete, and we're just going to have a look at the apparatus and you see how it works, right? So now the apparatus that we use in a titration, we have what we call a pipette. You see just now on our diagram. We use a pipette to transfer an exact or a fixed volume of a solution into the flask, right? It's very accurate. An indicator, we have touched an indicator before. An indicator is there to show when the end point has been reached in an acid, right? In an acid-based reaction, titration. For example, we can use methyl orange, we can use phenolphthalein or universal indicator. So the indicator is just there to tell us whether the reaction has ended or not. Okay, so we have what we call the burette. This is a narrow graduated glass tube with a tap at the bottom, which is used during titration to deliver the exact volumes of solution. Now we have our diagram. I want you to have a look at it. So, okay, this is our burette, this one. It is graduated and it's having a tap there. So you can actually control how much of the solution that is in the burette you want to allow to enter in this conical flask. And that's a pipette. A pipette is exact, In this case, we are having a 20 cubic centimeter pipette. That's the one that we use to transfer liquids, right? So now we have what we call the conical flask. I'm sure you guys are familiar with this flask at the bottom. That's our conical flask. What does it do? It allows the mixture to be safely swirled without spilling. So as we'll be doing our titration, you open the tap there for a short while, you close it, and you'll be swelling this conical flask to mix properly the contents, and then you observe if there are any changes. You add again a little bit on your conical flask, you swirl it left, right, to see if there are any changes in the solution as you be pouring the contents in the burette, right? We have got a clamp and a stand. This is our stand, it's holding our burette in place in vertical perfect position, making it easier for us to measure accurately. I'm sure you can see the eye where it's looking at, right? So now let's do a titration. We'll just run through a titration. We'll just be talking about it. Unfortunately, I don't have the equipment for practicals. So what do we do? Okay, at first let's add 25 cubic centimeters of our sodium hydroxide to a conical flask. What are we going to use? A pipette. It's very exact, right? We just use a pipette to fill up our conical flask with 25 cubic centimeters of what? Of sodium hydroxide. After that, add a few drops of indicator. You can choose the indicator you want to use. For example, in this case, we're going to use phenolphthalein. And this phenolphthalein, we're going to use it to determine the end point of the reaction. And we said, how do we see the end point of the reaction? we see it by a color change. When you start observing a color change, just know that that's the end point of your reaction. And then add the dilute acid from a burette slowly while stirring. You add it from the burette slowly while stirring until indicator goes colorless. We know that the phenolphthalein is colorless in an acid. Once the phenolphthalein starts changing color, be moving from red to colorless, it's a sign that the reaction, we have reached the end point of our reaction, right? It means that all the alkaline has been used up, and now the solution is neutral and no more acid must be added, right? So any color change simply tells you that that's where your reaction should end, right? So at the end point, that's very important. The volume of dilute hydrochloric acid that neutralizes 25 cubic centimeters of dilute sodium hydroxide solution was accurately determined, meaning to say, at that point where your sodium hydroxide changes color, when the color now is changed and it's becoming colorless, you can go back to your burette and see how much of the hydrochloric acid had I poured into this conical flask. So in other terms, you have noted down the amount of hydrochloric acid that is required to neutralize 25 cubic centimeters of sodium hydroxide. Now, the whole experiment should be repeated. Why are we repeating it? To obtain an average value of the volume of hydrochloric acid needed, called the titra. So, when you're doing experiments, you don't just do one experiment and then you give a conclusion. You repeat this thing maybe 5 times. After repeating it, the same process 5 times, you can now take the average of all the volumes that you got and work with the average, right? So now, you must repeat without the indicator. Put 25 cubic centimeters of the sodium hydroxide in the flask and add the correct amount of acid to neutralize it, right? So now, finally heat the solution from the flask to evaporate the water. White crystals of sodium chloride will be left behind. Remember, when we react our hydrochloric acid and sodium hydroxide, what we get at the end of the day is water and the sodium chloride, right? So now, let's move on to the calculations, which are very important. We are going to look at them on our next video.